we're going to use a technique from the machine learning literature known as k-means classification. How many people know what k-means classifiers are? Okay, good. Most of you don't. So I'll tell you. It's not complicated, but it's kind of cool. So I want you to imagine a bunch of objects depicted here graphically on the left. And the objects in gray are the ones that I want to classify. And the features, the characteristics of each object is two-dimensional. That's why I'm plotting them on the x and the y-axis. So their position, this point here versus this point here, indicates the value of characteristic 1 and characteristic 2. Okay? And I'm looking at this, and I kind of think and believe that there are 3 groups. And don't tell me why yet. I'll explain in a minute where that comes from. But for now, let's suppose that I believe there are 3 groups. And the 3 groups are different in terms of their characteristics. And the dots represent what I consider to be the average value of members in group 1, group 2, and group 3. So I come up with that. I propose that. That's exogenous. Okay? Now, if I have these values for the red, green, and blue, I can come up with a classification of all of the objects. And my rule is this. I'm going to calculate the distance between one of these objects and each of the dots. And I'm going to call this gray dot either red, green, or blue, depending on which dot it's closest to, just in terms of distance. Okay? So if I do that, if I use that method, then it turns out that this one is a red dot, but this dot here is green. In fact, all of these dots here are green until we get to this dot. This dot is closer to blue. And then all the way up here, these are blue. So if I use this nearest neighbor algorithm, this is what I get. I get this classification. All right? Any questions about that? I'm not done with the classification. This is just what I'm going to do initially. OK. Now that I get these 3 groups, I'm going to recompute the dots. Because you see, the dots are meant to express the mean, the average value of the group. So now that I've got red in this group and red in this initial value, I'm going to calculate the average. And now I'm going to get a new red dot over here, similarly with the green and the blue. Whoops. So now the dot moves. And this dot moves, and this dot moves. And once the dot moves, I'm going to redo the exercise and calculate the distances all over again and calculate new groupings. And then I get this. And I'm going to do it again. I'm going to calculate the average value for the red dot and the green dot and the blue dot, so these are going to move. And then I'm going to calculate the distances, and I'm going to do it again. And I'm going to do it again and again and again and again until it converges. And hopefully, it converges. There are some mathematical proofs that show that under certain conditions, it will always converge. But it could be slow, so it could take a while. So you can only do this if you have powerful computers, hence the whole machine learning era where these methods would not have been practical 20 years ago for large data sets. But now, we can do them. Yeah?
So in some cases, like most of the cases you're saying, like
yeah.
It doesn't, so the final result doesn't depend on your initial choice of the...
You hope. But the way you do that is you start off differently, you rerun them, and you see. If the classifications are really correct, then it shouldn't matter where you start off. But in practice, it does, which is why you need to do sensitivity analysis and try different starting points. So I'm going to get to the starting points in a minute. That's a really important thing, the starting point. Okay? Because if you have a good starting point, it all works out. But if your starting point is stupid, if you pick, for example, if you pick as your starting point, 3 dots that are all close together, that's just dumb, right? Because you're trying to distinguish very minute deviations from each other. You want the dots to be separated because by definition, you're looking for different groups. So you got to pick good dots. what this amounts to in k-means classification is you have to pick what are called seed groups, seed values. So I'll show you in a minute. What we're going to do with trying to classify pharma versus biotech is we're going to use characteristics. That's the dimensionality, the number of features that we're going to compare distances to. These are the characteristics. There are 21 of them. For each company, we're going to calculate the number of employees, intangible assets, revenues, R&D expenses, stock returns, standard deviations, the whole gamut. Because our hope and view is that a pharma company is going to have very different values for these things than a biotech company. If it doesn't, then we lose. Then this method is no good. The hope is that these 21 different characteristics will capture the distinction between a biotech and a pharma company. And I think if you actually were forced to describe to me what a biotech and a pharma company is, without looking at this, I bet you that you would end up describing some subset of these features, right? Biotech company generally doesn't have drugs on the market. A biotech company generally doesn't have earnings. Biotech company generally has a small number of employees, so on and so forth. So I think we've got all of the features that we could easily imagine differentiating a biotech from a pharma company. But now we get to the point of specifying the dots. So what that means is that you can't just start k-means classification randomly. Well, I guess you could, but it would be very painful and you wouldn't get a lot of good results. You have to start by telling the algorithm, what do you mean by a pharma company? What do you mean by a specialty pharma company? You need to give them a starting point. And so let me give you an example of what we did in this paper. For pharma companies, we said Johnson & Johnson, Pfizer, Genentech, Merck, Pfizer, Amgen, and Wyeth, these are all pharma companies. Oh, sorry, Pfizer's listed twice. Mistake. So we give the algorithm these companies, and it calculates the mean values for those 21 characteristics. And that's the dots for pharma. And so what it will do is it'll go through all of the companies that are in our database and calculate the distance to this particular seed value for this 21 vector and look for the closest one. And then it will call that company a pharma company when it is closer to that than all of the others. Now, what are the others? The dot for specialty pharma is Forest Labs, Valiant, Gilead, Jazz, Pacira, Salix, Shire. The seed companies for early biotech are these companies, and the seed companies for late biotech are these. And so the question is, do you think this is reasonable? If you don't think it's reasonable, then you may not like our results. But the hope is that our results aren't that sensitively dependent on these initial conditions. So the way that you would test that is you start off with a different sample of seed companies, run your analysis, and see whether or not you get similar results. And we did that, and we do get similar results. It's not that complicated when you think about it, because as long as you use enough data to be able to capture these features, you should be able to classify these companies reasonably well. Okay. And then finally, the last category is all other companies. We put them aside. Kara?
I just have a hopefully quick question, but like on the slide that you were showing the dots, there are like two axes. So how do you factor in all those 21 variables? Like how do you make dots from 21?
Yeah, so this requires a leap of imagination. Instead of a two-dimensional picture, you need to imagine a 21-dimensional picture.
So you do them all at once, though. It's not pair some or something.
Correct. All at once. So features, so this has two features, right? We can imagine having as many features as we want. And so let's just do three features, because I can actually do three. So if you have three features, then that means you're a point in three-dimensional space. So if you start off with specialty pharma here and regular pharma here, what you're going to do is for any arbitrary company down here, you're going to calculate the distance between here and pick the one that's closest.
Okay, and the dots that you were picking in this 21-dimensional space were the categories.
Those are the averages from those four different categories, exactly. The way I calculate a dot is I take a look at all of these companies and I calculate the average value of net revenue, average value of number of employees, average value of ... and so on and so forth. And that will give me one dot, which is a dot in 21-dimensional space. And then I look for the things that's closest to that dot and categorize that as one of the four. Yeah.
Could it be the case that at the end, actually, when the machine learning picture converges, one of your ex-ante assumptions, for example, Pfizer, not Pfizer, the big Genentech is a pharma company, ends up being in the color of the biotech?
It could be, yes.
And then you have to make manual adjustments, so to speak.
That's right. Well, not manual adjustments. It is possible that, well, first of all, Genentech is part of your seed, so you don't necessarily put it in there. But what you may find happening is that ultimately it ends up getting close. You have two dots that get close together. And if that happens, then what that tells you is you made a mistake. And actually, instead of having 4 categories, really you only have 3 categories. That's possible. So the algorithm can do that. And so that's one of the reasons why this is also a bit of an art as well as a science. It doesn't always give you clean results. It depends on garbage in, garbage out. If you've got good seed companies, you can actually get good results. But if it turns out that the categorization is really not sensible, it's not going to work out. For example, suppose I decided I wanted to have, I don't know, Republican pharma companies and Democratic pharma companies. I could propose that, but my guess is that that's meaningless and it's going to end up coming together.